hello, good morning, good evening, wherever you are. My name is Mark Borstein. I am the CTO of Tremo Security and co-author Kubernetes and Enterprise Guide, and my illustrious and infamous co-host Scott Zarovich.
Illustrious. I don't know, man, but I'll take it. Thank you, man. Hey, I'm Scott Srowich. I'm principal engineer, primarily dealing with Kubernetes at a tier one global financial institution.
Works. So we got a real interesting one this week. I know we're going to be diving straight into demos. We're not going to spend a lot of time on banter. However, if you are out there, out in the anywhere in the verse and you're watching and you want to say hello, we've got the comments open and we will absolutely say hi. And we got our first taker here.
Got Jack.
Jack.
Jack made it.
Oh yeah, Jack. So welcome to the show. And this one's a real interesting one to me because so often when we talk about Kubernetes, we're talking about a cluster, right? Like we're just talking about what's going on inside our cluster, maybe about how to access it. But this one's real interesting because we're getting into one of the most enterprise IT things in the world that is so poorly understood in global load balancing. And the excuse me, and the difference between like global load balancing, hey, I have a load balancer, right? And kind of some of the how that's just so incredibly different because one is I got this box that sits between me and my users, and another is I'm doing DNS and I'm having fun with DNS. And so it's just like I think a lot of people don't really appreciate how important global load balancing is and how it's different than like, oh, I just have a load balancer up there.
Yep, I would agree on that, Mark. It's yeah, because when you talk about it, what is a GSLB or global DNS or global load balancing in this case? Really, manipulation of DNS records, and that's kind of what we're going to kind of get into. But yeah, you hear the term global load balancing, and then you think about load balancers, they're just not the same. But
right,
you know what, and I think what you're alluding to on that too, Mark, is right in the enterprise. You got multiple ways to do this, but let's assume you're going to have a course of production in a DR site. You got to fill your applications over, right? And typically you're going to do that at the application level because you're going to have 500 namespaces, 1,000, who knows, right? And it might be just one app, could be the whole thing. And it's kind of stuff we're going to get into in this. It's a definite, from, sorry, I'm seeing some names pop up. So,
yeah, no. Hey, Pradeep. Hey, thanks for coming and joining, saying hello.
Yeah, absolutely. And Jack is from our CNCF book club family.
Yep.
So awesome to see him make it into here. So what we'll talk about today is going to get into chapter 5, like you were saying, Mark, right? 2 different sections. One's going to cover external DNS, okay, and then one is going to cover, as Mark was saying, global load balancing. And that global load balancing will be using a product, or I should say an offering, that's a CNCF project called KateGB. I'm a big fan of it. The team that wrote it, Yuri being one of the primary leads on that. You'll see him on the LinkedIn feeds. Always very helpful. The team has done a ton in a pretty, I'm going to say a short amount of time. The product's evolved, it just keeps going. Adding different providers, down the line. We're going to deal with it primarily from a on-prem idea. Doesn't matter, works in the cloud as well. But we're going to link it in with enterprise DNS servers. In the example, I'm going to use Windows, right? And yeah, we don't want to open up the book of who uses DNS and Windows for enterprise. I'm like, I believe it or not, a lot of people, because Active Directory has it. So some people just kind of piggyback on that and say, I've already got them. So it doesn't matter. You can use any DNS. And there's a lot to these setups. And I think, like Mark, you were saying, it's new to a lot of people, right? I mean, at least at this level, you probably know what DNS server is. You point to it and you're like, cool. But there is a lot behind the scenes in DNS, right? So we'll get into that. And anything else, Mark, from your side right now?
I mean, I guess one of the things that I'm kind of interested in is in beyond seeing the labs. I know we're going to be diving pretty much right into the labs, right? Because these labs get pretty in the weeds. Um, the this has nothing to do with what we might call federation of clusters, right? Like, is that even still a thing in Kubernetes?
Yeah, KubeFed 2 is still out there. There's of course some alternatives now though. They're kind of building on that. Whether you get like Submariner, lots of different solutions, or heck, you can even get into the idea of Istio. We won't in this section, right? Because you can do cross-cluster mesh in Istio. Now you're dealing with different DNS type of global DNS on that, different from what we're talking
Right.
about here. But yeah, definitely, like you were saying, not federated.
Well, we're just talking about at the network layer accessing the clusters. If keeping the two systems in state, in sync is a
Yes,
whole other ball of wax.
yes. So this
Can of
idea is
worms.
you're deploying your workloads twice, heck, at least twice, right? This could be 3, 4 times.
Right.
We're going to deal with just 2 sites, but we can do more than 2, right?
Right.
It's just we're going to deal with just 2. So yeah, you have to deploy your app into both. No different than say virtualization today or even physical servers that you might do. So, well, I shouldn't say it because it's much easier in containers to do that, right? It's just kind of change your target point and go. And of course, you could be using something on the front like control plane, App Engine from VMware.
Right.
We got Kafka back this week too.
Yeah.
And Bonjour, which I'm sure I
Bonjour,
didn't
my
say anything
friend.
close to the correct way, but hey, awesome to see everybody again.
Cool. So do you want to share your screen and we'll just dive right into the labs?
Sure, I could do that. Mark,
So
let me make
I've
sure my
got the PDF of the book open. Where are we going to be getting started with
pretty
external
much to
DNS and
be
core DNS?
yes, you're in chapter 5,
Yep.
right? Gonna pull that up. Let me just make sure I got the right screen to present. It should be this one. Okay, let me get rid of that. So you
Sweet.
should
So I'm
just
going
see
to go ahead and
my
pull
Stark
off.
Industries, right?
Yep.
Okay, making sure I have the right screen up there. Yeah, so as you were kind of saying, Mark, if we're looking at the book in general, it goes right into the topics, right? I mean, some of the chapters there's more intro, okay, and the reason there's not so much in this one is if anybody happened to look at the second edition, this used to be part of chapter 4, so it's just kind of a flow. We wanted to break it out simply because, well, chapter 4 was getting to be almost a book by itself.
Yeah, I think we had gotten up to like 70 pages for that.
It was getting close, and that was
in the
taking
second
stuff out
edition.
too. And I was like, I don't want to do that. So we felt, let's make it its own chapter. So if you were to get into it, you're going to see you don't get right into too much on saying, okay, here's the background, because there's still DNS. We talked about DNS in chapter 4. Of course, we're dealing about internal Kubernetes DNS at that point. So, going through this chapter, we talk about the external DNS project first. So this is a little bit, I don't want to say it's less fun than KGB, but it's just different. So I'm going to say primarily what you're going to use this for would be exposing your services in your cluster that are not layer 7 primarily. Another asterisk next to that. What I'm really getting into is you're going to deploy Mongo. You're going to deploy, database as a service. Now, when you start deploying these Postgres, MySQL, LOA, whatever you're going to deploy, you don't want to use IP addresses, right, to connect to those. We're going to use MetaLB to assign our IPs like we showed in chapter 4. But to make those easier to consume, we need DNS records. And you can't really do that, right, by default. Absolutely, your service is going to get a DNS entry in core DNS in the cluster, but that's only accessible to the cluster workloads themselves, right? So how do we get this external? And that's where external DNS comes in. So what you can do with your external DNS is it'll just register the name that you want into a zone, and that's what we'll kind of discuss in here, and make it accessible to the outside world by name. Now, what's great about that is your IP on your service for the load balancer could change. As we know, they don't, they stay. But if you deleted the service and recreated it, and let's say the MetaLB IP went from .40 to .60, that's okay. External DNS is going to say, oh, yep, update, boom, name is good. So standard dynamic DNS, right? That's what I'm going to call it. Not new.
And how does time to live get
Oh,
complicate
that
that?
one, huh? That gets very complicated. Well, and that depends which layer of TTL, right, Mark? So what Mark's getting into is records have time to live on them. So why do they have these? Because typically you might hit the same name multiple times quickly. Do you really want that to have to go every time to the entire chain of DNS? So because of that, you can set TTLs on these. Now that's TTLs on records that you can do at the the zone and the DNS servers. But there's another TTL that can really wreak havoc. And Mark, you've probably run into this because you do a lot of web type applications. Windows has a TTL for DNS records. Windows also has another TTL for web records. So Linux is a little bit less, but Windows is, I think, by default 10 minutes. And
What do you mean by a web record?
Well, so there's a TTL for the DNS, but there's also a TTL for the TCP connection based on HTTP traffic. So I actually ran into this myself. I could see that the record updated. I could even look at my local cache in Windows that says, okay, yep, it's now pointing over here. However, in the browser, it was still going over there. So there's a lot of things to consider on that.
Interesting.
It's a great topic, Mark, but wow, that gets into
that really does get into. I mean, the amount of pain I have felt over the years, because I think Java fixed this in 11, but once upon a time, Java just ignored TTL, and that would cause no end of pain. Like there was a setting that you had to do to be like, hey Java, can you please respect TTL and go relook it up, because this just isn't funny anymore.
Yeah, no doubt.
And then what's the other one? Not that we're going to get into it, but lately I've had a lot of fun with DNS over HTTP issues, where browsers want to pull DNS from someplace else. I'm like, no, I've got DNS for a reason. Stop.
Yeah. Yeah, there's definitely, and then understanding the flow in that too. Like people think you had a second DNS, it automatically uses it. The first one doesn't see it. We could definitely get into a lot of discussion on DNS.
And that's why whenever there's a problem, it's always DNS.
Yeah, I'm used to that.
Every single time, without fail.
Any product I quote unquote own, right, wherever I happen to be working, we're always the people blamed, right?
Yep.
Any Kubernetes, you can blame the same. So what we're going to get into, got a lot of little theories, is into chapter 5 now. So you should see my screen that has the chapter 5 on it. This is a typical VM that we use in all chapters, right? So if we were to get the nodes on this for an example, you'll see it's the standard cluster we deploy from chapter 2. In the chapter 5 folder, we've got basically everything we need that we're going to demo. The one we're going to cover right now, because it's external DNS, is going to require two things. And that's going to be an etcd, another etcd, and the external DNS components. Now you could, I wouldn't suggest this, but you could use, I'm going to say the etcd is here for the cluster, but you should not. So we're adding another etcd because we're going to tell core DNS to go use this for storing the records. So what I'm going to do first.
So now, just out of curiosity, are there other options, like maybe a relational database instead of etcd? Like is MySQL or Postgres supported? Something that, maybe
core DNS has a couple. Mark, I don't know all of them that are supported.
Okay.
Right, because
I just know that managing an etcd on its own is a bit of a dark art. It's not quite as well widely known as, say, a MySQL or something to that effect. So even, because how many of us that are managing Kubernetes, even if we're on prem, you know the ins and outs of etcd the way we probably should in order to manage Kubernetes.
Agreed. Agreed. Now, the one thing about this, like in some instances, you talk about etcd, you probably a little bit different if you had, I'm guessing something like a V cluster, right? Let's not, again, we're going into topics we'll be talking about in future chapters, but the information in this is just records. We can get those from, they'll recreate. So it's not necessarily the end of the world if we were to lose it. But yeah,
Right.
absolutely. I absolutely agree, Mark. So what we'll do, because again, time just gets so fast. We run the script in here that we include to help everybody just not to type everything away. This one's pretty straightforward. We're just
You
saying,
might want to make that text a little bit bigger. It's a little hard to see.
oh, is it? It's really big on my screen. Let's see
Well,
if I
you
can do it
also
once
got
more.
one of those ultra wides set up.
I do.
I do find having the narrower screen gets a lot easier to see.
That's an 18. Fine. Is that
I might go a little bit bigger.
pretty soon? I'm
Yeah,
going to type two letters and it's going to word wrap.
just with the ultra wide. Like, do you have like a instead of doing it on your monitor, could you do it on the laptop screen itself, like pop open the lid?
Well, it is. Yeah, I'm doing dual, so I
Oh,
could
okay.
attempt that.
That's usually what I end up doing when I'm doing the demos, just because I find that it makes it a lot easier to
Well,
see.
let's get an opinion. Apologies, everybody here. So let me get over here and just change the screen. So I'm going to go up and present. Okay. Tell me how this one looks then. Although I got to change the font if I'm coming down here.
Yeah, you gotta make the font a little bit bigger. It's
Bigger? Dude, this is already
yeah,
scrolling like no tomorrow.
I know it's tough, but unfortunately
I don't. It's going to be impossible to show people anything.
yeah, I don't. It's just weird. Like, I don't know if it's because you're on Windows or what, but it's just the sharing. Like,
Shouldn't be anything to
it's
do with
really
Windows. I mean,
jacked up.
I'm actually at a 20-point font right now.
Yeah, like it's not sharing a particularly high res.
This bottom screen is only running 1920. So
Like,
that
I don't know if you can jack up the resolution a little bit.
I don't think you'd want the resolution jacked up. You'd want it down.
Well, it's just what I see on my screen is very it's almost pixelated. Like, the true
Oh,
type
that's
fonts are
weird.
not showing real nicely. It's just a really poor share.
Let me see all my open windows.
Yeah, I was gonna say there's your
I mean, some of my 3D models.
what your 3D model you're working on.
Yeah, that one's a Velociraptor.
Nice.
So let me
A
see here if
real
I can.
Velociraptor or a Jurassic Park Velociraptor?
Jurassic Park one.
Okay.
Yeah, it's gonna go up front. So let me see here then. So am I still? Nope, that one's high. Let's see if we can make this. Yeah, you know what? This should already be set to this one.
Oh, that's
I'm gonna say
definitely
keep. Well, so
a
far, let
little
me
bit better.
pull up the session.
Yeah, I think that's better.
Yeah, I'll accept.
It's
Yeah, that.
crisper. It's definitely a lot crisper. I can actually read things now.
Yeah, it just rolls so damn much now. But okay, cool. Apologies to everybody. Never know when you're gonna share something out like that, right? So, gotta figure out something better for next time, because honestly, this is gonna be very challenging to use. So what we've done at this point is I'll just do a get pods for everything, right? Because it's not that big of a cluster word wrapping. So we've got this etcd here, which should be coming up. We're in a running, but it's not actually running state. And then again, this is the live demo idea. All right. So let's take a look at the logs on this thing. And that's in my etcd DNS. I have Kafka. I don't have it on here right now, but you're absolutely right. PowerToys is something you should always have on a Windows machine, definitely.
What's power? Oh, that's a bunch of power tools for.
Yeah, some pretty cool stuff that Microsoft should probably
Okay.
have as part of the base, but they don't.
I'll
Keep
be
going on
honest.
from here.
I so rarely use Windows that it's like, wait, this stuff, it doesn't just magically work the way it does on both Mac and Linux these days.
No, all the
I'm
stuff
never
that
gonna
MS
miss a
does
cheap
work.
shot at Windows. Sorry.
Yeah, well, I'd argue a bunch of that, Mark. You know me, but not the place for this. So, okay, we're just going to get an external DNS. Apologies again to everybody. All the other labs have worked very smoothly for us.
Hey, Scott, one more thing
So,
I would say is let's get rid of that. What is it? Export
yeah, the pop.
PS1 equals like
Yeah,
that
you
or
have it,
something like
Andy?
that. I just sent it to you in the private chat.
Yep. Hold on. So, what Mark's talking about, everybody, is just to change the prompt.
There we go. Yep. Just to make it a little easier to see everything.
Well, considering that, yeah, that output, because of the size of the screen, is the entire line.
Exactly.
Cool. Okay. So at this point, we've got the etcd out there. Now, I'm still having a problem with that, but I really want to get into KGB. I just want to go through this because I do believe that this is very beneficial as well for services. So we're just going to deploy our external DNS at this point.
And what do you mean by external DNS? Let's make sure we're level setting there.
Yeah, apologies on that. External DNS is a project, right, from the Kubernetes SIGs that allows you to basically register external DNS records. As we mentioned earlier at the beginning of the call, we know services get registered in Kubernetes DNS, but now we want to make these accessible. So it's just a project that allows you to register what you're going to have inside your clusters with some external DNS. Now, we say external, it can still be running in the cluster, but there's connectors for Cloudflare, you name it, for CSPs, it's out there, right? So there's multiple things that you can do with it and connections for it. It's a great little service for that, and really pretty straightforward. So in here we've got external DNS running now, right? So here's the pod, here's this. This is being configured to actually use the etcd. So if we look at the script quickly, so you can understand what we're doing in that, hopefully with all the way it's doing in this, right? So let's go to the top. So create the namespace, right? Now, because I want to have core DNS point to etcd for storing the actual records, I need to get that service. So what we're doing here is just getting the actual IP for the service so I can configure my external DNS to use that. So we get that, put it into a variable for etcd. Like we do in many of the labs, if anybody follows these, we use a template, and of course we use sed to just replace values. So I'm taking the core DNS config map, and I'm going to add in there the etcd so it can get deployed. So it then tells it how to use etcd for the storage. So let's see. Let's go into this one again. Let's see what config maps we have in here. Nope, wait, nope, I'll go to another one. Oh, one of these days, my typing. Okay. So what we're going to notice in here is I'm going to look at there's a reason I'm doing this. So hold on. Forgot about that. I'm going to format that way. So because that was edited, I can't do it. There's a JQ for that, right? It should be this one. Okay, much better. So in our Kubernetes core DNS, I'm actually adding the new domain called foowidgets.kates. You know, I'm adding it here because for the demo, I just want to show you that names get registered. So I'm going to show that by using a pod to show you the records in there. So all we did is say, okay, cool. Yeah, we're going to be doing this. Go here. Here's your endpoint. That's the etcd that was found. And oops, wrong one. Oh, I hate when I do that. Close the window for anybody that's, you know, following along at home, which means I now have to change the font back. Okay.
So while you're doing that, I'm going to answer
Oh, I didn't see a question.
Pradeep's question here. So no, we're not replacing Metal LB. The point of external DNS is to be able to propagate DNS entries from inside of your cluster out to an external provider so that other people could leverage those names, right?
Yep. So like in this case, Pradeep, you did a MySQL, right? And you're going to expose it to people. You can do it by IP, right? Because you need a load balance IP for that because it's not running at layer 7. But you don't want people to use an IP to connect to it. So you want to register the name that you want so people can target a DNS name, right? Externally, right? In the cluster, they can always use Kubernetes DNS, but that's why we're getting out of this. It's no for the external names.
This is so that we can expose our load balanced IPs via DNS in a cloud native way, rather than, you know, what I end up doing, which is going to my Route 53 console and just typing in what the IP address is.
Yeah, absolutely on that one, Mark. And that's the key point. You could have probably records, depending where you work, to say, hey, I want a new A record. Hey, networking, can you go do this for me? Well, the problem with that one too is going to be, what if your IP changes in Metal LB? I mean, now go update the record. We don't want to do that, right? This is the whole idea of shift left. We want the developers to have everything that they need to make that work from the start, not, oh, I got 50%, let's go fill out a form.
Right.
And down the line. So in this example, we're going to do just a quick kind of Nginx deployment. If I were to take a look at this one, you see just deployment, service. Here's the key point on this one. So how do you register these? You have to add an annotation now to your service. And I'm telling the service here to register nginx.foowidgets.kates. Pretty straightforward. Nothing else on here looks weird, right? This is all standard. It's a load balancer type, you know, going on up, just standard deployment. Nothing, you know, super cutting edge or confusing. Let me change the prompt, guys, back to what we have. So I'm going to get out of here. Okay. I am going to deploy this. And I see, Pradeep, you have another question. We'll let me do this part.
Well,
first.
let's get through the demo and then we'll answer that.
I'm doing that quick. So we can see here, deployment created, service created. Okay. Pretty sure I put it in default. So we can see that.
Please don't ever put things in default at home, kids.
You do not, but for a fast
Just
demo,
saying,
you can get away with it. So at this point, let me look at the pods again. And we're going to take a look at, and of course it's crashing. Why does this have to happen during a live demo?
Well, you figure out what's going on. I'm going to answer Pradeep's question. How about that? So you can expose an internal service using either port forwarding in my router or use like a Cloudflare Connect. Yeah, you could. I would, I don't love either of those situations. I'll be honest. And one of these days we're going to do we're going to take a break from the book and do, like Scott likes to call them, an excursion. I like, WireGuard VPN. I'm new to the WireGuard train. But you know, there's also, you could go with something like an inlets from which lets you do something like that. And then what's the other one? Tailscale? Is that the other one I'm thinking of that's gotten popular?
Could be.
To be able to do
There's Gronk too, which is really
Gronk.
popular.
That's the other one
Yeah,
that's really
that's a good one.
popular. So yeah, but those are definitely ways to do it. But really, what we're talking about here is if you're thinking about in an enterprise, you know, once you've created an application, you've deployed the application. That application has a name, and so one scenario that you can do is you can have a wildcard, right? Where you say star dot everything in this domain points to this load balancer. And that's pretty common.
But that's
And
only
that's a,
for like layer 7 though, right, Mark?
well, that's a right,
Yes.
right. Whereas what Scott is talking about here is being able to give you the ability to say, you know what, have you a little more flexibility where your app owners might have control of their host names, or the host names don't follow a typical a standard naming convention, because I know this will come to a shock to many people watching, but enterprises don't always maintain the best naming standards, and even when they have them, they don't always follow them. um
Absolutely.
and so giving this scenario where you could say, you know what, my host name that I'm associating with this load balancer is then easy to uh is then pretty easy to um expose to your developers, and avoid the whole email shuffle. It looks like, Scott, you're making
Hard.
some progress here.
It's semi having another issue with the etcd, but what I really wanted to show in here is, and it's good, you can see that the external DNS operator or controller did in fact see the request. So it added the record. So that's what this is telling you, that the external DNS controller is saying, oh, okay, cool. You wanted this, it's been added. Now, I am still having, again, those issues here with this etcd still having issues coming up. And it probably has not registered the entry because of that. However, we're going to do a very similar thing with KGB. So
Okay.
we can get into that one and explain it a little bit differently. So yeah, this gets confusing to a point. All the things you mentioned pretty, yeah, it's one way to access your stuff, but that's more of the connection, right? How do you
Yeah.
resolve the names there? And I think the KGB really drives it home to me. And the reason I say that is you'll see more of the DNS names and how we're going to work. So let's go to that one instead. I have two. Yeah, let me do this again. And I tried to prep as much as possible to, but without cutting corners where you might not see certain things. Okay. Now, in most of the book, as we know, we use kind, right, for everything. And kind works great for everything that we do. However, for KGB to show real impact, I need to have two clusters, right? And I actually want to show it from an external client as well. So what I'm doing now is I have two single node clusters that run kubeadm, or they're going to. Actually, at this point in time, they're not running anything. At least they shouldn't be, right? Nothing here. So in the, so the problem I have in my path, Chapter 5 folder, under the KGB example, we've actually got a kubeadm directory. And what this will do is simply spin up a quick cluster for us. So I'm going to just do create kubeadm single. I've already done this before, so that's why it's asking, do you want to overwrite this and that? It's trying to add an entry. Now, at the same time, we're going to need two clusters here. So let's get over to the second cluster. Still the right one. Okay, let's let that create while we're doing that as well. That one archive takes I think the address on this one changed. This one takes a little while to time out. So I'm going to hop over to the chapter quick. And we'll get down into that section down here, which is, that's integrating. Here we go. Load balancing between multiple clusters. And this is what Mark was mentioning. So we now have a deployment. We're going to have an Nginx web server that will demonstrate. It'll be running in production, and we're going to cause it to fail. Right now, that means all my users have to now go to the other cluster. And that's why we need to have something like KGB, something that's going to, or some load balancer, right? We're going to talk about KGB. So KGB is going to know, oh, the one over here is down, go over here. So we have two clusters. We're going to call one Buffalo and one is New York City. And we'll switch between those.
New York City.
Yeah, well, I got to put that in there for you Yankees fans, Mark. So what this does is the global load balancer basically, or this KGB, updates DNS records. It's the easiest way to describe it. And we should have something deployed here. Oh, come on. What bad luck do I have?
Did you
today?
forget to sacrifice a live chicken to the demo gods?
Well, yeah, especially like network not reachable.
Are you on a VPN?
No. No, and all of these were tested twice this morning. I definitely don't come in totally cold. Yeah, nothing. Wow, everybody watch live troubleshooting now.
That's the great part about live streams, right? We didn't want to do these pre-recorded.
No,
we
no.
want to show it in all its glory.
Okay, good. It is that one repo's been causing the some problems. I got to update all that. This is not script related, nothing related. This is this VM. I should say both of VMs because they're just clones of each other. So you can see this one's going to take a little while too. And then it gets stuck here again. But you can see it does connect. Cool. So I'm going to kind of jump around a bit. This is why in the book, in the chapters, we don't really ever call out the exercise to say, go do this, right? We include all the steps, but the two clusters are one thing, which, by the way, for anybody, listening or watching later, I added a new script to the excursions in our GitHub that actually will create two kind clusters on your single host by just adding two IP addresses. It's all fully scripted. It'll just ask you for what IPs you want to add, spins up two clusters that have different IPs. So therefore, you've got two API servers on different IP addresses, two different ingresses. And from there, I'll expand it some more. But you can do everything I'm doing here with my kubeADMs, except with kind. You'll still have a problem external people coming in because of the way the Docker is, but you can at least play around with it. Now that's only the first half of the battle. You're going to see a lot of terms in the chapter if you're reading about KGB called edge DNS servers. I'm not a big fan of calling them that because everybody thinks edge, like Jack on here, right? Edge to him because of where he works. He's going to be thinking what most people think with edge. It's really, I'm going to call it your corporate DNS server, your main DNS server, whatever you want to call it, right? So in our case, I mentioned earlier, we're going to use Windows. So this is a Windows server running. I have a domain called foodwidgets.kates. Kind of mentioned this. I can't do much on the size on this either because this is actually I can't just size it.
I can see it. Yeah.
You kind of see it. Okay, as long as you can kind of
get it's not too bad.
So it has two A records, and these are actually going to end up being the core DNS servers running in your clusters. Okay, and there's a reason they have to be named a certain thing, and this is the way KGB looks things up. Now, that's all you need in here, right? You got a new zone, calling it foodwidgets.kates. We have then two records that are going to be the DNS servers. But Then we have to forward things. And what we have here is something called gb.foodwidgets.k8s. This is my dynamic DNS zone, I'm going to call it, that I'm going to use for KGB. Okay, and all it's going to do is anytime you try to resolve that, it goes to your main DNS server, which internally this is my main DNS server, 10.2.114. That Windows server is going to say, oh, you want something in gb.foodwidgets.k8s. It'll then conditional forward you over to the core DNS servers, right? And this is where DNS can get complex, right? A DNS query is not just one. Kafka got in a little bit late. We figured this kind of stuff would
I
come
will
up.
never miss an opportunity to take a cheap shot at Windows, and I will not apologize.
Yeah, admittedly, Active Directory integrated zones work pretty well, and all corporations have it.
Yeah, that's
Right?
true. That is
Because
true.
you're running Active Directory most likely.
Yeah.
Now, granted, the other reason I did it this way, I can graphically show people what's going on.
Yeah.
I mean, I'm going to be honest, it's just the easiest way to me to say, okay, cool, here you go. So this is a RDP session into there. We don't need to look at this again, right? Because we don't actually do anything on this. It's just delegating it out to us.
I mean, so when I open up my browser and I go to foodwidgets.k8s, it's going to go hit that DNS server. It's not hitting the DNS server directly that's running in your cluster.
Yeah, it's those recursive
hit,
queries.
Yeah, it's going to go hit your AD DNS server, which is then going to forward the request on to your internal DNS inside the cluster. So it's not the addresses aren't being replicated up to
Right.
AD. They're being forwarded back down. So my enterprise pushes out DNS servers, based on my domain, right? So I have a DNS server, it goes to that, but then that request to that DNS server is then going to get forwarded down for foodwidget.k8s onto my cluster.
Yep. Like standard internet, right? Everything goes to root. Then it goes to, oh, you want .com, .edu, whatever. Boom. Oh, you want this. Oh, you want this. It's usually, 4 to 6 hops of a lookup just to say, oh, cool, because we got to go all the way down and delegate. You could picture if we put all this in one huge zone file, right? Every DNS record on the internet would be a pretty big file.
What's the worst that could happen?
Oh yeah, nothing wrong with terabytes. And, we can parse that in no time, right, Mark? So yeah, what I'm gonna do here is I'm gonna look up something that doesn't exist yet. All right. So as Mark was saying, doing an NS lookup for a record we are going to create. So an NS lookup is a tool to just look up a DNS, tell you what's going on. As Mark stated out, yep, it's going to 10.2.1.14. That is my server. Right now, we don't have one, right? There's no entries in here yet, and that's what we need to configure still. And as the two are building out in the back, yep, starting up kubelet. We are slowly getting there because now it's doing Nginx. This is really not running like it normally does.
Do you have this running on your local VMs, or you got a?
Oh no, this is a actual
ESXi.
Yeah. I'll just make sure I close anything I don't need over there, though.
Yeah, I think one of the things I'd love to do, maybe after next week or the week after, when we get a little bit, because next week we've got authentication, the week after we've got authorization with RBAC. Maybe we take a little break and talk about some home labbing, and what folks can do, because we do talk about home labbing in chapter 18, but I feel like we're starting to get to the point where you can get into some really fun stuff, and maybe talk about what people could do for their home labs.
Yeah, that's a good idea, Mark. So many people automatically assume like Raspberry Pi, for an example. Nothing wrong with that, but they don't know about, as we've talked about, and I have a bunch of these, the Windows or x86 based SBCs.
Yep.
So you got single board computers that are pretty much just a little bit more expensive than Pi, but yet you don't have to worry about having to get ARM-based images or anything else. So we can argue that anyway. So some people are going to be supporters, some don't care. I happen to use x86 for most of my. I have a ton of Raspberry Pis, just not for Kubernetes. right? I ran into issues with certain CNI testing and that. Okay, so if we do get nodes over here, I said they're just a single cluster, a single node. Let us make sure, do I have, yeah, let me go back on the, okay, that should be easier to see then. This would be the Buffalo cluster. And we have the New York City cluster coming up. So give that some time to build. Over here, as we said before, this is the exact same thing. Sorry, get pods from basically from chapter 2. It's close enough to it. It's running on kubeadm, but so we don't need to be in the kubeadm one anymore. Instead, we will, do I have metal LB? I do not yet. I need to have metal LB running because we have to expose our core DNS to the actual, a layer 4. We can't do it on a layer 7, layer 3, 4. So I'm going to install metal LB buff. So if you're actually doing this eventually, on your own clusters, you got to choose the right one because of just the way I do the IPs. Now, these are all explained in the README file that you just got to kind of replace values, right, for your own. So quickly, metal LB. And we talked about this in chapter 4. Right? We're big fans of metal LB. It's just too easy to do what we're going to do here. Give it a second to deploy. It doesn't take long.
So we got a couple of questions, comments. Your forwarders are the 2 external DNS services running in the Kate's cluster. That's
Good
what
question.
the Kate's GB is doing, right?
That's what we do. So when you deploy Kate GB, which we have not done yet, there's an option to say deploy core DNS with it. And that's what we're going to do. And we'll actually show that.
Okay, cool.
So we'll definitely get into that. So we can see metal LB added. That's all good. Now we go into the Kate GB directory. And Kate GB also, you got to deploy the correct deployment with the cluster you're on. And again, we're on the Buffalo one, right? So we're going to just say, let's deploy KGB buff.sh. So it's going to add it all. It's going to do the namespace. I've created a web server as well. Actually, not a lot had to happen here, right? It was pretty quick. Get the pods on here. We'll now see in KGB. Here's a core DNS popping up. That's the KGB controller itself. And this is actually something we'll use for the testing. It's an Nginx web server. So it should be pretty quick. Core DNS will come up. Let's look at the service in the demo. Okay. So we have it running. You'll notice it's not using a load balancer service. It doesn't need to. If we get all the services on the cluster, we have, this formatting on the screen is driving me crazy. You're going to notice we have a Kate GB. And this is actually running in the Kate GB namespace for core DNS. And these are exposed. Now, you don't need both. I'm actually doing both for another reason. DNS uses port 53, right? TCP and UDP. So which one is it? It can use both, right? It depends on the process, size of the query, zone transfers. So you probably don't need both, but I expose both. Because if you do want to zone transfers, if you want to do bigger queries, it could
big host names.
Yeah, there's a lot that can happen.
Big enough host name can break a UDP.
Yes.
Not fit everything in one UDP packet.
But you'll see that a lot in docs that I read. People say, just do this with 53 UDP, and I'm like, oh, you're going to cause yourself a lot of headaches and tough ones to track down, to be honest.
Yeah.
So at this point, you're going to notice here, 10.3.1.120. This is the core DNS server going to produce question. I'm going to go over to my Windows DNS server. one of my entries in the main zone has the .120. Right? You're going to notice it's hard to see. Apologies, it's on the Windows screen. It is US-buff. I know that's my Buffalo server. The GB domain is told to delegate off to those, and it's delegating off to 120. So if I were to, again, live demo, let's hope now that this one. So fe.gb.footages.kates. We can see it resolves now. Okay, earlier it didn't because that zone had nothing in it. So it's coming up and it's saying, okay, you want to know where this is? Footages. It's at 10.3.1.19 or .91. So what's that 91? Go back to the Buffalo cluster. You're going to see that it's the Nginx ingress controller, right? That's where all of them have to go. This is layer 7 traffic. It's like, okay, cool. Go to the Nginx ingress controller. So go one more step now. We can see it from an NS lookup, but what's this thing actually look like? Let's make sure that copied correctly. Let me open up Chrome. You can use any browser on this, right? But obviously I don't have a science certificate on this, but I hit it through the KGB managed record. It says, hey, welcome to the web server in Buffalo. Okay, not, again, super exciting. Yeah. So we got the Buffalo cluster. We can see I've got that deployment. I've got core DNS working. Let's finish off the other cluster. So this is the New York City cluster. It is now running a single node. You can see it's KGB-NYC is what I called it. We need MetaLB on this. So this MetaLB is being deployed with the IP range and pool that I wanted to use for this cluster. What we'll then do is deploy KGB, and let's see what happens now with our records. So KGB has a lot of different ways to do these failovers. The documentation's great. They got some great examples up on their website and their Git. We are doing just failover, right? So it's always going to go to the primary unless it's down. It's going to go to secondary. Primary comes back. It's going to come back there too. So it's automatic failover, fail back. Some people like that. Some people don't. Change it. You can make it round robin hot. You can do it so many different ones. I think there's 5 or 6 off the top of my head. So we can see everything's running. MetaLB is good. So we go over to KGB again. Make sure we're deploying the right one, which would be New York City. Creating config map. Creates the record. All good. I already had one in there. It's just a service. Doesn't matter. Should look very similar to our other one. There's that one Nginx. Going to what you were saying earlier, Mark, right? So this Nginx is now deployed in both. I, of course, wanted it to, you knew where you were going. So this Nginx will say, welcome to New York City, right? This way we know what's going on. So everything is good. Okay, cool. I'm going to go back here on my workstation. I'm just going to do this real quick. It's still 91. Okay, well, the reason it's going to keep coming up with 91 is it's actually running right now. It works, right? We already proved that here. So refresh this. Okay. We don't want anything going to New York City unless the Buffalo one is down, right? We're not set up for hot or that right now. We're set up for just failover. And we go through the steps in the book for this as well. But if we were to look at our deployments in demo, we've got the Nginx. I'm going to simulate a failure. Let's crash Buffalo. Let's try that again.
You
Just crashed.
have a dash instead of an equals for your replicas.
No, actually, it's dash dash. Oh, I'm sorry. At the end, I'm sorry, Mark. No, actually, it is equals. You can't see it on
Oh,
the
is it
screen.
equals? Okay, it was just the.
Oh yeah, because it even says scaled.
Yeah, you're right.
No, you have, yeah, because I saw what you saw on the screen too. Okay, so pods, it's not there anymore, right? First thing we're going to do is let's do an NS lookup on this. Notice what the
Oops.
changes to.
Yep.
I'm sorry, what, I was going to say, oops, don't say oops, that's working, Mark.
Well,
So,
no, oops, it something went down because it failed over.
gotcha. Yep. So 60, sanity check, right? We're going to get all of the services on the New York City cluster. And you'll see that 60 is Nginx ingress. So it's now going to go over there. Okay, let's go over to the browser now. I'm going to do this. Advanced.
New York City.
And there's New York City. Okay.
City's so nice they named it twice.
Absolutely. You had nothing to do with this, right? Nothing to worry about. It just automatically did it. So now we're going to come back here and let's rescale the Buffalo instance. Okay. Now, as this is scaling, let me see how fast I can get over here. Still 60. Still 60.
Does Windows have like a watch command?
PowerShell has
every
something
second?
in it. Yeah, PowerShell does, but it's not. I don't know if it's just watch mark or if there's another parameter for it. There is something in the PowerShell for it. So you can see now it is back to 91. On average, it takes about 5 seconds for a cutover. Certain things can be tweaked, but you want to keep that in a sane level.
Yeah.
Right? Some people go, I want 1 second. No, you don't, because that means all the heartbeats are going to be like just denial of servicing as you scale too. You don't want to necessarily do that. And if I go back over here, this is what I was hoping to see. So I mentioned this earlier, Mark, right? It says New York City. Okay, well, I'm refreshing. What the heck? It's still saying New York City. So I'm going to say, okay, do Control F5. That's fine. This is that browser portion. It's also a feature in Chrome that has this too. I mean, we know that my workstation is in fact resolving this to 91, which should say Buffalo, but it's not. So what I can do over here is just to force it. Now it's back in Buffalo. So that one setting there, I think, is actually a pure Chrome setting that can be edited.
Sorry, what did you do to force it?
I closed the browser.
Okay.
Close browser, reopen it. So this is not a KGB thing. It's nothing like that, right? They adhere to different TTLs. Plus, I didn't really tweak any of the TTLs in general for entries. So, and this time can fluctuate as well, right? Because the way it does its clock, you might see a change in 3 seconds, but it might take 20, 30, 40, just because you never know where you're jumping into the clock.
Gotcha.
So if you were to, I mean, the chapter goes into, better details. I'm going to say more details on this because all the magic that we did here. First, let's look at how we set up KGB.
And just a quick time check here, Scott. We're coming up on the top of the hour.
Yeah, I see that. It's always one of those little issues. When you configure KGB, it's really simple. This is setting up the value style. And we kind of talked about these, what zone do you want to use for your, I'm going to call it your dynamic entries in this case, right? Your GSLB records. And I'm using GB.F, which is that case. The edge DNS is, well, what's the domain in the main DNS servers that we're going to delegate out? And this is where your DNS servers have to be for core DNS. The tags are where it gets interesting. This is going to say this side is going to participate in a KGB, I'm going to call it cluster, right? It's more partnerships and tags, but I'm calling it US buff. Okay, now what other KGBs will I work with in partnership? Well, in this case, US-NYC. Probably not surprising, the New York City one would look very similar, except the tag would say US buff, right? So they're both saying, now I have 3 other ones I want to add. Go ahead, you can add these. Logging, straightforward, right? How do you want to log all this stuff? The core DNS questions that came up. You can say, is it a cluster service? This means use the one that's in K8s. It's false by default. And in this case, we're saying, you know what, for the deployment, I want to use the one that comes with KGB. You might have your own extra core DNS, who knows? Then we're setting it up for a load balancer type and the IP address I wanted to assign. I'm assigning the IP, right? I had to because I'm forwarding. I didn't want that to break in the middle of a lab.
Right.
And then the way I expose my workload, as we kind of talked about a little bit now, is it's a new kind called GSLB. It looks very similar to an ingress rule, right? If you're looking at it, for all intents and purposes, it really is. You set it up like an ingress. We're just saying FE, down the line, Nginx port 80, with the one difference down here is a strategy. And this controls how that record's going to work. In our case, it was failover. Like I said, I don't want to go there unless the production one's down.
Right.
You can change that to other values as well. Round robin, you can do geo. Geotagging means, well, that's great. Let's do hot. But if you're in Buffalo, I want you to hit Buffalo all the time by default. But in New York City, I want you to hit New York City, right? Why go
Makes
across?
sense.
Yep. So pretty powerful stuff. Again, big fan of shifting this over where developers can do everything. You get a namespace, bam, you got it all, including DR. The other reason I also like this is it's its own record type, its own kind GSLB. So if I needed to query a cluster, like in production, and make sure everybody's ready for a DR event, I just look for this record type in everybody's namespace. If I don't see one, you probably don't have DR, right? That's a huge problem. Today, how would I even do that? There's no way. If it's on the F5, for an example, I need to get access to the F5 and do things. But this allows you to do simulated failures, anything, right? So very powerful. It's also a lot to digest quickly.
Yeah.
Without a doubt.
Just want to, Kafka mentioned something about support for split brain DNS. I'm not entirely sure what that means. You probably know what that means more than I do, Scott. With
when I
split
hear
brain.
split brain, I usually think about clusters.
Yeah, but it sounds like being able to have multiple data sources or multiple forwarders, maybe for depending on where you are in in a replication.
Yeah, 2 versions of the zone. It's very true. I mean, and I know people pick on a Windows DNS server, but they have a lot of powerful stuff in it.
Oh yeah, I'm sure they do. Doesn't stop me from picking on them because it's Windows.
I mean, it is just DNS, right?
Yeah. And then Pradeep, no way to stop fallback. That's going to be one of your configuration settings, I'm sure.
Yeah.
Because if you're failback, that's what you want, is to fail back when the source cluster comes up. So that's probably more of a, pick the right strategy that works for you.
Yeah, I was looking for the list, but there's strategy options. In the website, I'll just show it quick, just because I can. So for an example here, if you, like I said, they have a great website. They really do. This goes through what you can set and how they work. So like round robin, weighted round robin, so you can do percentages. Here's your failover. And then there's GeoIP. But that returns the closest. So it's a good question, Pradeep. I'm going to look to see if there's some kind of a tweak we can do at failover. Typically, when you see a failover in products that include it, it automatically does go right back, right? And you can set that up with clustering technologies like VCS or other ones. You can say always use the primary if it's available and bring it back. A lot of companies don't do that because if it failed over, sometimes they don't even notice it. They want to know it's there and they want to know where it's running at all times. I personally am a big fan of the GeoIP because I want to run a lot of hot workloads, to be honest, right? Especially Kubernetes workloads. Chances are you can run the majority as a hot. And then I don't want you crossing that wire if you're in, Hong Kong and suddenly you hit a US server. That makes no sense. So have you pin over there.
Awesome, man. Well, we covered a lot. I'm not gonna lie, that demo was cool.
Apologies on the issues with the text.
Yeah, but it's one of those things that like, oh, there's a web page. Awesome. Wow. And it's like, no, do you understand how much automation went into just showing that little web page and making it work properly and the DNS going back and forth?
Here's where I go to
Yeah,
that
no,
one statement I use a lot, Mark, right? If it looks simple on the front, it's complex on
so
the
much
back.
work going on in the back.
There's a lot of
So
little components there.
yeah, and that's just a cool project. All
Yeah, again,
right,
I'm
so
gonna say hats off to that team and Yuri,
yeah,
right? They just
absolutely. That's a great project.
awesome
Hats
group
off
as
to the
well.
KHGB team.
Yeah, definitely.
So okay, so we are at the end of the hour. Went over a little bit, so we're gonna wrap things up. Next week, near and dear to my heart, authentication, my favoriteest thing in the world.
You are gonna brush up on it, right, Mark? I know it's new to you. So
Yeah, I haven't done a lot, but it should be a fun new
just you can read
experience
a
for
half a white
me.
paper. You're good.
Yeah, so we're gonna hop into authentication. Uh, Ladies and gentlemen, and boys and
Thanks, Jack.
girls of all ages, everybody. Hey, Jack. If you have bought the book, especially on Amazon, please take a moment to leave a review. It makes a big difference, huge difference, especially if you've bought the book from Amazon. You can even do it anonymously. You don't have to put your name on it, but it does make a really big difference to where we show up on that list. So to help spread the word. Thank you, everybody. Scott, as always, thank you. And we'll see y'all same bad time, same bad channel next week.
Excellent. Thanks, everybody.